This video is about applications of quadratic functions, and so this is like word problems when it becomes useful. So the first example that we have says it's about maximizing an area. It says a homeowner has 80 feet of fencing to enclose a rectangular garden. And what dimensions for the garden give the maximum area? So he wants the biggest garden he can make, and it's going to be in the shape of a rectangle. So all I've done so far is drawn a rectangle. So I recommend that you draw any kind of picture you can think of that goes along with the word problem. So they mentioned a rectangular garden, so let's draw a rectangle. And what they tell us is he has 80 feet of fencing. So that refers to the perimeter. So you buy fencing in chunks, and so this plus this plus this plus this. If he wants to maximize his area, he's going to use all of the fencing that he has. So let's begin to label some variables. Let's call this y and this x, this length x and this length y. And since it's a rectangle, we know that this is also x and that this is also y. So we can come up with a formula using the 80 feet of fencing that they gave us, saying the perimeter, which is always just the distance around something. Now there is a formula for rectangles that they say 2L plus 2W equals to the perimeter, and that's fine, but also you don't need a formula for perimeter because it's always just adding up the distance around something. So even if it's an irregular shape, you just add up all the different sides. So the perimeter is x plus y plus x plus y, which is, if we want to collect like terms, 2x plus 2y, okay? And that's going to equal to 80 feet. This is one equation that we get here. Okay, what they asked us to do in this problem was to try to maximize the area, find the dimensions that make it the biggest. So, the formula for a rectangle, the area of a rectangle is length times width, or in this case, area is x times y. So what we need to do is get our area formula, which is what we want to find the max area. That's our goal. Okay, we want to find the maximum area. Get it all in terms of one variable, either x or y. So I'm going to solve for y here and get it in terms of x. So I'll do this by subtracting 2x from both sides. 2y is 80 minus 2x, and then I'll divide both sides by 2 and get y is equal to 40 minus x. Now I want to make this substitution. I'm going to substitute this in for my y here. And when I do that, what I get is that the area is equal to x times 40 minus x. All right, so what have we done so far? We've read the problem. We have done our best to understand what's going on here. It's a rectangular garden. These are the dimensions, and we want to maximize this area. Now, we came up with the formula for area in one variable. That was the next thing that we did. So now let's have a look at this. I'm going to distribute the x and see what this looks like. So the area is equal to 40x minus x squared. And if I want to rearrange this, and all of a sudden, I put in this, instead of just a, I call it a of x, because now it's a function of only one variable because we made that substitution. So a is a function of x. So a is equal to negative x squared plus 40x. So let's just remember what we have learned in the last few lessons about quadratic equations and quadratic functions. This is quadratic. It's got an x squared. The leading coefficient is negative, which means it's facing down. So at this point, I'm going to kind of draw a picture, a sketch of this function. It's very much a sketch. But the point is it's facing down and it has a maximum, right? And the max and the min, whatever way it's facing, always occurs at the vertex. And the vertex we are familiar with. We can find the coordinates of the vertex. And so what this is going to tell you is what x value will give a maximum. And what this k is a of x. And this is going to tell us the maximum value that we can get. So that's how we would interpret this h and this k. So h, if we memorize that little formula, is always equal to negative b over 2a. Well, what is B in this case? It's 40. And what is A in this case? It's -1. So H is going to be -40 over 2 times -1, which is -40 over -2, which is 20. All right, so we found out that the coordinate here of this parabola is going to be, the x coordinate is going to be 20. This is the value of x, and k, our y, is a of x, because this is the function a of x that we're modeling here. All right, so how do we find a of x? We plug it into the function a. So a of 20 is equal to -20 squared plus 40 times 20. And so this is going to be -400 plus 2 times 4 is 800. And we get 400 is the max area. This marker needs to go. So the maximum area we can get is 400 square feet. And when x is 20 feet. What did they ask us in this problem? They said, find the dimensions of the garden that would give us the maximum area. And so if we know that x is 20 feet, once you find one variable, you just substitute it into any equation that you see, like this one would do, or this one would do. And I'm going to plug it in this one and get y is equal to 40 minus 20. And so y also is going to be 20 feet. So the dimensions that will give a maximum area. So I'm going to, instead of writing out the sentence, this is what you should write down if I ask for a sentence. The dimensions that would yield a maximum area of 400 square feet would be 20 feet by 20 feet. Okay, something like that. All right, let's do number 2. Now we have a picture of a barn, and it says, a farmer wishes to enclose a rectangular region, another rectangle, with fencing as shown in the diagram. Now the diagram, this is different than this little rectangle. This is our diagram. Here is his fence, but part of the fence is blocked in by the barn door, right? So the animals can't get out that way. So he doesn't need fencing along the red. He needs fencing only where the black is. Plus he's splitting up his pen into 2 pens. He has 3 parallel pieces going that way. So that's what we noticed about. This is different from the last one. And it says, suppose x represents the length of the 3 parallel pieces. So over here is x, x, and x. All right. So that's what they told us. What else did they tell us? Oh, she has 600 feet of fencing available. So that's how much is available. Somebody's calling. Let me just see what this is. Oh, this is the math office. Hang on a second.